Hello and welcome to this video that goes through exercise 9C from the Statistics and Mechanics Year 1 AS Edexcel textbook. We will go through questions 1 to 5. So question 1, a particle is moving in a straight line with constant acceleration 3 meters per second squared. At time t equals 0, the velocity of the particle is 2 meters per second. Find the velocity of the particle at time equals 6 seconds. So here in this situation we've just got a particle moving in one line like this, and the first thing that we should do in these questions is write out our formulas S, U, V, A, T. Now as it's in one dimension, we only need to consider everything in one dimension. So here we write out, fill in as you go along the as you read the question. So here's straight line with constant acceleration, which is 3. So we know that our acceleration is 3 meters per second squared. At time equals 0, the velocity of the particle is 2 meters per second. So we know that our initial velocity is 2 meters per second. And find the velocity of the particle at time equals 6 seconds. So we want to find this value, and we've got 6 seconds. So therefore our S value we don't know, and we don't care because we only need 3 known values and 1 unknown value. For these set of questions we're going to use the Suvat equations. I will write them once here. You are given them in the exam. So v squared equals u squared plus 2as. S equals ut plus half at squared. V equals u plus at. S equals u plus v over 2 times t. And S equals vt minus a half at squared. So for this question here, we're looking for an equation that doesn't have S. And that's going to be this equation here, v equals u plus at. So from here we're going to plug that into our equation. We're going to write that out. So v equals u plus at. V is what we want to find, so the question mark is equal to u, which is 2, times 6. I misread my own formula. So it's u plus 3 times 6, which is our at. So from here it's equal to 2 plus 18. So our value is going to be 20 meters per second. So at t equals 6 seconds, final velocity is 20 meters per second. And that gives you your answer for question 1. For question 2, a car is approaching traffic lights. The car is travelling with a velocity of 10 meters per second. The driver applies the brakes to the car and the car comes to rest with constant deceleration in 16 seconds. Modelling the car as the particle, find the deceleration of the car. So here we've got the car. It's initially travelling at 10 meters per second, and then at the end of this situation it is travelling at 0 meters per second along the line. So from here we can write S, U, V, A, T. So it wants to find the deceleration. So first of all, car is approaching traffic lights. The car is travelling with a velocity of 10 meters per second. So U is equal to 10. Driver applies the brakes and with a constant d comes to rest. So again, here comes to rest. So that means that V is equal to 0 meters per second in a constant deceleration in 16 seconds. So we know that this is 16 seconds. Modelling the car as a particle, find the deceleration of the car. So we want to find what our acceleration is. We don't care again about our displacement. So again, the same as the previous question, we look at our formula sheet and we know that we're not looking for an equation, we're looking for an equation without S. So we're going to use V equals U plus AT. You can do this with 2 ways. You can substitute your values in straight away, or alternatively you could rearrange your equation to find it in terms of A. So that will be V minus U equals AT, and then V minus U over T equals A. Whichever method you choose, plug in your numbers either at the start or after you've rearranged it, so it becomes 0 minus 10 divided by 16 is equal to A. So it's minus 10 divided by 16, and then plug that into your calculator. You should get minus 0.625 meters per second squared. So it says, again, you can leave your answer as minus 0.625. You could also see that the deceleration of the car is 0.625 meters per second squared, because you made it clear it's a deceleration, so therefore the acceleration that we're talking about in this sentence is going backwards. However, leaving your answer as minus 0.625 is perfectly fine, because the examiner will know that you've taken going forward as positive. Question 3. A car accelerates uniformly while travelling on a straight road. The car passes two signposts 360 metres apart. The car takes 15 seconds to travel from one signpost to the other. When passing the second signpost, it has a velocity of 28 metres per second. Find the velocity of the car at the first signpost. So here we have the car, and this is the first signpost, I suppose, is here. And we then know that there's a second signpost. We know that this distance here is 360 meters and t is equal to 15, and we know that the particle, when it travels at this point here, has a v of 28. So again, we write our SUVAT and fill it in directly from the question. Again, drawing it out is an optional part. You don't have to draw it out, but it might help you think about what's happening in the question. So S is equal to 360. Car takes 15 seconds, so it's 15 seconds here. When passing the second signpost, it has a velocity of 28 meters per second, so we know that our final velocity is 28. We want to find the initial velocity, so therefore we don't care about our acceleration. So if we go back to our formula sheet, we're looking for an equation that doesn't have acceleration, and that's going to be this equation here, the fourth equation, S equals u plus v over 2 times t. So we are going to write that equation in. So S equals u plus v over 2 times t, and again we're looking for u in this equation. So this time we're going to plug the value straight in rather than rearrange, although you can rearrange the equation. So you get 360 is equal to u, which we want to find, plus 28 divided by 2 times by 15. So then from here we can, first of all, multiply both sides by 2. Multiply both sides by 2, we get 360 times 2, which is 720. So 720 is equal to 15 times u plus 28. So therefore we're then going to divide by 15 on both sides. So 720 divided by 15 is 48. So 48 equals u plus 28. Then become minus 28 on both sides. So therefore 20 is equal to u. So the initial speed at the first signpost was 20 meters per second. And that is your answer for question 3. Question 4. A cyclist is moving along a straight road from A to B with constant acceleration 0.5 meters per second squared. Her velocity at A is 3 meters per second, and it takes 12 seconds to cycle from A to B. Find her velocity at B for part A. So again, we can draw out our situation. You don't have to draw it out, but it might help you understand what's going on. So we've got between A and B. We know that the person has a velocity of 3 meters per second at this point, and we want it takes us 12 seconds, where A is equal to 0.5. So we're going to start off with our SUVAT. So SUVAT. So we know that the acceleration is equal to 0.5 meters per second squared. We know her velocity, so her starting velocity when she's at A is 3 meters per second, and we know that the time is equal to 12 seconds. So for part A, we want to find what the velocity is, v, so we're going to write that as v, and we're going to use an equation that doesn't have s, which we've used a couple of times already in this video, v equals u plus at. So we're going to plug our numbers, so we've got v equals u plus at. We don't need to rearrange because we've already got v as our subject, so we say u is 3 plus 0.5 times 12, so it's 3 plus 6 is equal to v, so v is equal to 9 meters per second. So that gives us our answer for part A. Then in part B, we're going to find the distance from A to B, so we're going to find our s value. Now it is very tempting to use your answer from part A, however we have enough values, essentially we can use an equation without v to be able to find our answer for B, for our distance, without using our previous answer. This is, if possible, highly preferable because it means that you're not using potentially a mistake you've made in the first part. So if you can use another equation rather than using a value, I would be more preferable to do that. However, you can essentially use any equation that you prefer. If we go to our equations, the equation that doesn't have v is s equals ut plus half at squared. So therefore we can plug that in. So it's going to be s equals ut plus a half at squared. From here, s is s, so we don't need to rearrange. It's going to be 3 times 12 plus a half times 0.5 times 12 squared. From here, we just plug that directly in the calculator, so 3 times 12 plus a half times 0.5 times 12 squared, and plugging that in, s is equal to 72 meters. So the distance from A to B is 72 meters. You can write a sentence in the exam. Unless it specifically asks for a sentence, you can just show your answer, and that's perfectly fine to collect all the marks. The final question of this video will be question 5. A particle is moving along a straight line with constant acceleration from a point A to a point B, where AB is equal to 24 meters. The particle takes 6 seconds to move from A to B, and the velocity of the particle at B is 5 meters per second. Find the velocity of the particle at A and the acceleration of the particle. So from here, we have got A and B. We know that that distance is 24 meters. We know that the time taken is 6 seconds at B, and we know that at B the velocity is 5 meters per second. So from here we're going to write out SUVAT, and our first question is find the velocity of the particle at A. So here we're looking for our initial velocity. We know that the distance between A and B is 24 meters. We know that the final speed, we know that the particle takes 6 seconds, so we'll fill that in first, and then we know that the final velocity is going to be 5 meters per second. We don't know A in this part of the question, so we're not going to use A, but we know we need it for B, so we're not going to cross it out yet because we can keep the same SUVAT situation. So first of all, we want to find the velocity for B, so we're going to use an equation that doesn't have A. So if we look at our equation that doesn't have A, it's going to be our S equals U plus V over 2 times T. So from here, for part A, S equals U plus V over 2 times T. Here we can plug in our values, so it's 24 equals U plus 5 divided by 2 times by 6. Times both sides by 2, we get 48 equals 6 times U plus 5. And then we can do 48 divided by 6, which is equal to 8. So it's 8 equals U plus 5, and then we can subtract 5 from 8. We get 3 is equal to U. So the speed at A is going to be 3 meters per second. 5b we've got is the acceleration of the particle. So here I'm going to use an equation without U. Now this equation is going to be S equals Vt minus a half at squared, although if you're not confident using this equation, you can use any of the other equations available because you do have your answer for U, which is 3 meters per second. So from here though, we're going to use S equals Vt minus a half at squared. From here we're going to say this is 24 is equal to 5 times 6 minus a half a times 6 squared. So that's 24 equals 30 minus 6 squared is 36 divided by 2 is 18. So minus 18a. And from here we're going to rearrange. It's going to be 24 minus 30 equals minus 18a. 24 minus 30 is minus 6 equals minus 18a. And then minus 6 over 18 is equal to a. No, sorry, it's going to be minus 6 divided by minus 18 is equal to a. And therefore, from here, minus 6 divided by minus 18 is the same as 6 divided by 18, which a is equal to a third. So here, if you can do, just write the first few significant figures of a recurring fraction. But here's a is equal to 0.333 meters per second squared. And that is your answer to question 5. If you have any further questions, please let me know.